tracks. These properties can be defined using a variety of To define a specific number of grid lines and tracks, use grid template columns and grid template rows. This will create an explicit grid. These properties are declared in the grid container, with the values expressed as a track list, separated by a space to designate the number of tracks. These properties can be defined using a variety of value types. In this course, we'll mostly use pixels and two new units and values I'll be discussing right now. The grid layout introduced a new flexible length unit, FR. This represents a fraction of the available space in the grid container. If the value of grid template columns is set to 1 FR 3 times, that will split to define a specific number of grid lines and tracks. Use grid template columns and grid template rows. This will create an explicit grid. These properties are declared in the grid container with the values expressed as a track list, separated by a space to designate the number of tracks. These properties can be defined using a variety of value types. In this course, we'll mostly use pixels and two new units and values I'll be discussing right now. The grid layout introduced a new flexible length unit, FR. This represents a fraction of the available space in the grid container. If the value of grid template columns is set to 1 FR 3 times, that will split the grid into 3 equal columns. But if the value is set to 1 FR, 2 FR, and 1 FR, the grid items will still be arranged into 3 columns, but the second track will take up twice the amount of the first and third track. The same logic applies to grid template rows. We can also define multiple tracks using another value, the repeat function. Instead of writing 1 FR 3 times, include the number of tracks, 3 in this example, followed by a comma and the size of the track, such as 1 FR, within the parentheses. The repeat function can also be used to repeat all or just part of the track listing. Different units can also be mixed together. In this example, our first column is 50 pixels wide, and our next two columns are equally spaced. Gutters can also be added between grid items using the gap property. One value adds the same amount of space between the rows and columns. Two values sets the gutter for the rows, then the columns. Gap can be used with any length unit, the calc function, or a percentage, but not the FR unit. The gutter space can also be declared independently using the longhand properties. Row gap and column gap. Originally, the grid layout module defined the gap property as grid gap and the longhand properties as grid row gap and grid column gap. This property was updated to be used for both Flexbox and Grid. But right now, Gap is only supported for Flexbox in Firefox. But for grid layouts, Gap and the previous grid prefix properties are supported in all modern browsers. Let's put all of this together in an example. The first step is to declare the grid container. Down on line 3, let's add that in. The grid items will look the same, but now we can apply the grid properties. So let's add in 3 columns with grid template columns, each set to 100 pixels in width. Now we'll add 2 rows with grid template rows set to 100 pixels each. Let's try updating the column value using the repeat function. function instead. We'll add repeat with the parentheses, and back inside the parentheses, we'll add the number of columns that we want, 3, and the width, 100 pixels. The grid should look the same since we're only changing the way we set the value. To add or remove columns, just change the first value. Let's put it back to 3 columns, but instead of using pixels, let's change it to the new flexible FR unit instead. To create 3 equal columns, set the value to 1 FR. The grid will then split into 3 equal parts. Not only are these columns equal, but they're now also flexible. Let's resize the viewport to see how it scales. The repeat function can also be used with other values. Suppose I wanted the first column to have a fixed size of 100 pixels. Then the remaining space could be split evenly into 2 columns. I can do that by just adding 100 pixels as the first value and then repeating the last 2 columns set to 1 FR so that they can be split evenly. Since we use pixels for the first column, it will have the fixed size applied to it, but the 2 columns set with the FR units will still be flexible. So far, we've been making changes using grid template columns, but these value types and units can also be applied to grid template rows. And speaking of the rows, right now there are 2 values indicating 2 rows with a height of 100 pixels. Let's delete one of those values. Now the height of the second row is the same height of its content. It's no longer 100 pixels in height because we've only declared one explicit row. Any items that are within the grid container but are placed outside of the explicit grid will be placed into an implicit grid and will be sized according to those rules, which we'll discuss in the next lesson. We'll also be continuing with this pen, so keep this open for the next lesson as well. To define a specific number of grid lines and tracks, use grid template columns and grid template rows. This will create an explicit grid. These properties are declared in the grid container with the values expressed as a track list, separated by a space to designate the number of tracks. These properties can be defined using a variety of value types.